Hi, my name is George Moromisato, and I want to talk about a brief history of computing and how it inspired our product GridWhale, which is a cloud computing platform. When I was a kid, my dad brought home a terminal to the mainframe, and I got to use it. I got to play Star Trek. I got to play Adventure. It was pretty awesome. Mainframe programs are very, very simple. You just run a program on the mainframe. It runs on the mainframe. It calls some API to do output. So when the program says print this, calls some API. The platform sends it through some standard protocol to a terminal, which could be either in the next room or through a phone line to wherever the user is, and it would output the text. And when the user wanted to input something, you type into the terminal, and the characters would go through, and then the program would get it. So super simple to program. It didn't matter how many terminals were connected; they could all just go down to the platform. Eventually, though, mainframes are big, expensive, and eventually, they invented the PC. The PC is was better than the mainframe because it was personal. It was your computer. You could do whatever you want with it. And the PC had an even simpler model. There was no terminal. It's since the computer and the monitor were just right there with you. The program could have essentially direct access to whatever it wanted to its input and outputs. The platform, of course, still handled things like displaying windows, displaying graphics, the keyboard and all that. But if the program wanted to, draw a picture, it would call the platform and it would get displayed on the monitor. If it wanted to get mouse commands, it would, just get events, and then the program would handle those events. It's again a super simple programming model, and it was the personal computer revolution. It took computers really far. You could do a lot of things with just that simple model. The one thing you couldn't do though is share stuff across users. A single PC couldn't do very much. And so eventually we started connecting these computers together into a local area network. And in a local area network, in order to do something useful, you needed a different architecture. Now these programs had to somehow work together. This client-server architecture was kind of the most common way of doing it. Basically, one of the machines on this local area network would be the server, and you'd have a server program running on it. And the other machines would be clients, and they'd run a client program. And the client program would talk to the platform to display, graphics and whatnot to get input. And then through this custom protocol, it would talk to the server and tell the server, what the user wanted to do. And the server would, coordinate, store the data, do whatever it is. So no matter how many clients were talking to the server was responsible for kind of coordinating that. And then that's how you could share data. And it worked great. The only problem was the complexity, because now you're writing two separate programs, each with a different role, and the programs have to talk to each other or talk to the server in some, this protocol that you're going to make up, usually some, remote procedure type protocol. So creating these systems was not that easy. It took real work. So the next innovation, kind of in the history of computing, was the web. The web was, if you look at it, it's basically just the client-server architecture. The client is a browser program. The server is some web server. The innovation was that you could the programs that you would write were constrained to just generate HTML pages, and then those HTML pages get shown to the browser. So imagine a PHP platform. You'd write a bunch of programs that would generate these HTML pages, and then serve them out in the browser. There'd be links to navigate to the next page, etc. Mark Zuckerberg wrote all of Facebook that way. The first version of Facebook was exactly in this model. And notice he didn't have to write these two different programs. He didn't have to come up with some custom protocol. It was super simple. He just wrote this little piece that just generated HTML pages, and the platform took care of everything else. So that was the kind of the innovation of the web. Of course, eventually we wanted more power out of the programs in the browser. We wanted to be more reactive. We wanted to do more things on the front end. And so eventually with JavaScript and Ajax and other technologies, we came up with an architecture like this. The architecture is basically, there's a front end program, written in JavaScript that handles the user interface for the user. It handles clicks. It handles fetching data from the server, through some custom API, And there's a backend program, of course, that's coordinating and handling the multiple different connections. We're basically at this point we're totally back to the client server architecture model, except because this is the web and now we got to scale to millions of users. It's not that simple either. We have to, the backend is now a much more complicated system that has to scale out across multiple machines. Maybe it's decomposed into microservices, kind of each talking to its own little platform. Maybe it's there's a database system somewhere in here that's doing the persistence. And on the front end, of course, there's innumerable frameworks now that let you get just exactly the right type of user interface that you want on your front end program. So the complexity has, as you can see, exponentiating. And looking at this, I'm thinking there's got to be a simpler way. And in GridWhale, what we've done, the simplification that we've chosen, is to say, hey, let's take all this part, the scalability part, and let's move that on the other side of the platform. Let's put a platform layer on top of that so that the program just deals with kind of its own concepts, its own storage, its own, simple kind of structures. And the platform is responsible for scaling that out to however many users we've got. Moreover, rather than having kind of some custom code up in the client, let's take all those concepts, kind of the event-driven model, when users click, what you display at each part of the screen, let's move that down into the platform so that the program thinks that it's manipulating this essentially virtual window with controls and getting events and all that, but in reality it's the platform that's pushing that out to some browser client or some mobile client or whatever, and through some internal protocol that the platform handles. This is very much like a much more sophisticated version of the VT100 terminal, except where you're remoting more graphical user interface stuff. So with this kind of a model, you can see that the program itself can once again be a lot simpler. It's directly responsible for both the user interface and for storage and for business logic, and anything where it needs complexity, we push down to the platform. Now, this is obviously not a new model. There's lots of products already kind of moving in this direction. If you think about AWS Lambda is basically this model where instead of programs, you're doing these stateless functions. You're writing a little bit of functional code that responds to some REST endpoint, and that's sitting on a platform that does the scalability. So the program that you write, that little Lambda function, doesn't have to worry about any of the scalability problems. It's basically this exact model. The difference there is it's still stateless, so you still have to have connect to some database, talk to some database for state, and so you still have to deploy out some database system, and of course you still have to build your front end, because Lambda doesn't deal with front end. So GridWhale, the advantage there is you kind of get that integrated feel in this one development system. You get to deal with all the the UI and the storage in one, and so it's a lot simpler from a conceptual perspective. Another set of products that are following this model are all the low-code, no-code products like Bubble.io. They have a very, very similar model. They basically, in Bubble.io, you configure an app, and instead of writing code to do the app, you just design it using a visual designer, and then there's some rules about where the data comes from and how to manipulate data and all that. You kind of set up those rules. But it's the exact same architecture. The configuration runs on some data center on top of their custom platform, and then through their protocol they talk to some client UI and display the client UI, display the UI the way you want it to be displayed, and the program doesn't have to worry about that, or at least you don't have to write two separate programs. Your little program deals with everything. The downside, of course, is it's a more constrained environment, unlike in GridWhale where you're writing real code. In Bubble.io, it's constrained to whatever set of whatever systems they have, so it's a little bit more constrained. But it's the same model. If you think, if you look back through this kind of history, the way I've described it, we seem to always go in these periods where we increase complexity to accomplish more and more things and more sophisticated programs, and then figure out a way to reduce that complexity by coming up with abstractions, by adding more platforms, usually trying to move things to the platform to kind of make sure that programming is simpler again. And I think we're in that simplification point once again. I think we've kind of reached the end of complexity here, and we're moving towards this model, much closer to where this is. So this is where GridWhale is trying to go. We're going to kind of chart a path that's in between the complexity of this. We're going to be able to, it's going to be way simpler to do this because you just write a single program. But we're also going to be more capable than Bubble.io, low code, no code, because you are writing real code. So that's kind of the area where we're going to go, and the history of computing is one of the inspirations for us to get here. Well, I hope you enjoyed that. I'll keep you up to date on GridWhale. Thanks very much.